Hi everybody, this is Jill Richmond. The article I chose is called Foster Fact Fluency with Number String Discussions. It is from the October 2018 issue, and it is written by Wendy Bray and Luz Maldonado. Maldonado is a teacher in this article and uses this number string strategy with her second graders. I chose this article because I teach third grade, and I think the strategy would be beneficial to my novice learners. My targeted topics are number sense and basic facts, which I think this strategy would help my students achieve those skills. The purpose of the number string discussion is to have the students practice solving related problems and discuss the reasoning and relationships of the problems. I like this strategy because the entry problems allow students to start with facts they know and can build their fact fluency by practicing related but more difficult problems. The article first starts off by discussing a reasoning approach to fact fluency grows out of discovering the numerous patterns and relationships that interconnect the basic combinations. Teachers will carefully select and sequence the problems that will elicit discussions of particular strategies. Within the article, they later discuss how teachers will want to predict what types of strategies their students will most likely fall back on. This table shows you three different examples of number strings. One is a subtraction, a multiplication, and a fraction one. You can see that the entry point for the subtraction one is 30 minus 10, and by the end they will be subtracting 91 minus 35. While this strategy is still new and difficult for me to comprehend, you can see how they progress through the related problems with the string. After they solve 3 minus 10 and discuss reasoning and strategies, they jump to 32 minus 10. Since they just solved 30 minus 10, they will use this knowledge to help them solve each upcoming problem. And you can see how they jumped from 52 minus 10 to 52 minus 20, 52 minus 24, and so on. This page explains how Maldonado used the number string strategy with her second graders. The teachers decided to create a string to draw out the making 10 strategy in hopes that students would notice the relationships among the combinations of 10 facts and use their knowledge to solve for unknown facts. This figure shows the making 10 strategy. They developed the entry problems were 4 plus 4 and 5 plus 5. They were known facts for most of the students and provided a starting point. The next problem is 6 plus 4. And this was the making 10 strategy in relation to the 5 plus 5. The next three problems were related to the making 10 strategy. And the last problem was chosen for students to engage with less scaffolding. While Maldonado was using the number string strategy, she gave students time to silently work out the problems themselves. She used a think, signal, discuss procedure to allow students to solve problems on their own and then share with their peers. She also had students repeat the strategies that their peers had explained. This table shows the student strategies for 6 plus 7. Sorry, right, this one. And you can see that students use different strategies, such as direct modeling and counting on their fingers. The student used counting on, and then the next three were from derived facts. You can see her notations here. She used an arrow notation, not so that she didn't model an incorrect way for the equal sign. Here the article discusses how the number string lesson was carefully, oops, sorry, I went too far. Go back. Was carefully designed for the specific group of students. It points out that care was taken to ensure that entry points and engagement opportunities for students whose next step along the learning progression was to move from direct modeling to counting on. They said that a common problem for teachers is bringing all students into the discussion and finding their value of their peers' ideas. Maldonado modeled how to do that through the article, and she chose not only those who had correct answers or used fancy strategies, but those ones that she wanted students to pay attention to their strategies. The conclusion points out that repeated engagement in these fostered discussions over time does promote student reason, or sorry, the conclusion points out that the repeated engagement in these fostered discussions over time does promote increased fact fluency, and they can establish a strong foundation for using number relationships to derive or devise multi-digit computation strategies. Thanks.